Hello, students. I am going to go over lesson 1-3 that was covered this past week. This is specifically designed for students who were not here to listen to the lesson or just needed a refresher. So we're going to analyze key features of graphs in lesson 1-3. All I did in class was I went over several problems in each one of these sections, and then I just released students to work individually or collaboratively with their teammates. We will start here at finding the domain graphically. So you'll be given a sketch of a graph, and I'm going to want you to analyze it, specifically finding domain first. Domain has to do with the x values of this axis, what x values are being used to be able to plot this graph. I will always want you, when you are reading or writing out the domain or range of a function, domain will always be from left to right. So in other words, you start with the lesser numbers and work towards your greater numbers. When it comes to range, you will start from below the negative numbers. You'll start from bottom and work your way to the top. Okay? So going back to domain, domain means you will completely focus solely on this horizontal x-axis. And we are going to analyze and see what x values are being used to sketch this half circle. You will notice the furthermost left point of the graph is going to be -1. You're not using any x values to the left of -1. And to the right of 7, you aren't using any x values there at all. The graph starts at -1, ends at 7. Therefore, we know that these points are being included, so we're going to have brackets. So I'm going to type -1. It's going all the way to 7, and you're going to include the x values -1 and 7. And there you go. Let's try another problem. Here we have a function that's discontinuous. What do I mean by that? Well, if I trace this graph from left to right, that means I would start over here on the left-hand side. And if I placed my finger here and I go tracing it right here, I would have to stop, lift my finger to then come over here again to continue tracing. So I would lift my finger off the screen, so to speak. This is discontinuous. So that means that I am going to have more than one interval, specifically 2. So let us start from left to right. That means I'm going to give you what x values were used for being able to draw this side of the function and what x values were used for this. So this piece of the graph is going all the way forever to the far left. So I know that the furthest left value that we're going to use is going to be -infinity. And we're going to use all the numbers that are way, way, way negative. And we're going to come all the way this direction. And we're going to keep using all those x's until we reach -3. There's a full stop here at -3. So that -3 is included. So I am going to use this option, the parentheses and then the brackets. I'm going to have a -infinity, and I'm going to go all the way to -3. Since I have another interval, I'm going to put a union symbol, okay? And now I'm going to start. I'm not using any of these x values. Notice that. That's where I lifted my finger. These are not being used. When I sketch this piece of the graph, I am starting at 1. And then I'm going to go, and I'm going to use all the numbers to the far right forever, because this arrow means I'm going to the right forever. So I'm going to use bracket parentheses, bracket because I'm starting at 1, and parentheses because it's infinity. Notice that when it's infinity symbols, you will always have parentheses with them, okay? So that's it. So this interval notation says I'm using all the x values to the left, going to infinity, all the way to -3. Then I'm going to skip the numbers between -3 and 1. I'm going to start at 1 and go all the way to the far right. And that's how you do domain. So let's go back here and let's do range. Range is the same thought process, but now what you're doing is you're reading your y values from bottom to top. So what I need you to do is completely ignore this x-axis now. All I want you doing is focusing on this y-axis from bottom to top. So what y values are being used to graph this linear function? Notice this linear function is continuous. If I traced it with my hand, it would never lift up the screen. So therefore, I'm going to have only one interval. So what's the furthest down that this graph is going to go? Well, the furthest down this graph is going to go is negative infinity. And what's the furthest up this blue graph will go? It will be positive infinity. So in essence, what we're saying, it's all real numbers. So negative infinity to positive infinity says that the entire x-axis the entire y-axis, the range values are being used to plot this linear function. Let's try another problem. Here, this is a discontinuous function. So we need to focus on going from here, negative infinity, all the way to positive infinity. So we are going to notice, let's see if there's a way of me, well, I wish there was a way of me demonstrating, but I want you guys to notice that there's a break in this function. So using my arrow here, if I'm tracing this blue graph, right, I'm tracing, all of a sudden this graph drops, right? And then I have to lift the cursor up to come up here and continue tracing because I'm tracing from left to right. So there's a break in this function. So when I'm looking at this graph from bottom to top, I want you to notice that this particular graph is using all the negative infinity numbers all the way, and it stops right here. It stops using y values right here. So just to make this a little bigger, to give you a visual, a little clearer visual, okay? Notice that the graph, if I would draw a horizontal line, I would draw it right here against this -3 line. That blue graph stays underneath that -3 the entire time. Then what happens is that this graph starts, and this graph starts on the other side of -3, and it goes all the way to infinity, okay? So if you can picture me taking a ruler and drawing a red line right here, okay, that is called a horizontal asymptote. Horizontal asymptote. So both of these graphs are getting infinitely close to this invisible line that we usually depict with dashed as a dashed line, and it gets infinitely close to this y equals -3 line, but it never touches. Okay, so let me diminish the size of this a second. So what does that mean we're going to do? So you are going to start from the bottom. We have two functions, bottom to -3. -3 is an asymptote, and all asymptotes use parentheses. We're starting at negative infinity, way at the bottom, and we're going all the way to -3, okay, because there's an asymptote. And then we had to lift our finger up to be able to graph the other piece. And I'm going to put a set of parentheses again. After I jumped over this y equals -3 line, I was able to continue graphing from -3 all the way to the top, which is infinity. Okay, so from the bottom, negative infinity, all the way up to -3. And then I'm skipping -3, so to speak, and I start over again on the other side of -3 and keep going all the way to positive infinity. Okay. Let's see if there's another example. Let's try this one. Okay, so this one here is a continuous function. So I never picked up my finger from tracing this, right? Look, never stopped tracing. So that means I have one interval to draw or to write here. So again, range means the lowest y value. What is the highest y value? Well, the lowest y value is going to be this point right here. And the lowest y value that this U-shaped graph, this parabola, is going to have is -7. and that is a point on the graph. So I'm going to put -7, and it's going to go all the way up forever. These two arrows say that they're going up forever, infinitely. So let's go over to this side and put infinity, and there's our answer. Okay, let's move on to the next section I went over. We did visual composition of functions. So here's how this works. I'm going to also expand this. And when you're doing this, I highly suggest that you expand it too to make it a lot easier to see on your screen. So we are evaluating f of g of 1. Anytime you're reading this left to right, anytime you see parentheses, you use the word of. So f of g of 1, this is a composition of functions. You will always start from the innermost value, which in this case is a 1. The 1 is an x value that belongs to the function it's written next to, which is a g. So I need to go to 1, x equals 1, on the g graph. The g graph is right here. So that means I'm looking at this graph on the right-hand side, and I'm going to put my arrow at x equals 1. So right here is 1. Now, what I'm supposed to do once I know that 1 goes to the g function, I need to go to x equals 1, and I need to go touch my graph. In order to touch the graph, my g function graph, I had to go down 2 units from 1. So now I'm standing right here. I went down 2 units. Okay? So what does that mean? G of 1 is down 2, which is -2. So now what I'm going to do now is I have to evaluate f of the answer I just got from here, which in this case is -2. So f of -2 means I need to go to x equals -2 on the f graph now. So I'm going to go right here. Where do I have to go to touch the f graph? Well, in this case, I had to go 1, 2, 3, 4, -5 points down to touch the f graph. So -5 would be my answer. Okay, so I start with my 1 on the x. I had to go down 2. And then I came over here to the answer from the previous composition, and I go to my graph again and I had to go down 5. And that's my answer. Let's try another one. G of f of -8. So I have to start at -8. Where? On the f graph. Here's my f graph. So I go to -8 on the x-axis, and I have to go touch the f graph. So I go up, how many units? 6. So now that I know the answer is 6, I will substitute this with the number 6. So now I'm looking for g of 6. G of 6 means go to 6 on the x-axis and go touch your g function. Well, if I'm standing here at 6 on the x-axis, I have to go up 1 unit to touch my g function. So 1 is my answer. And that's how you do composition of functions. Next, the next thing we went over, let me go over one of these. Testing whether the graph is a function or not a function, or one-to-one or not one-to-one. So to test if it's a function, it needs to pass the vertical line test. So as you can see, me drawing a vertical line would fail because it would intersect the graph more than once. Okay? But here, let's look at this graph. Is this graph a function? Well, if I draw a vertical line every single time, it touches only one time. So that means my answer is going to be function, but not one-to-one, or one-to-one function. It can't be this one. So between these two, how do I determine which function is it going to be? Well, in order to prove that it's one-to-one, it has to pass the horizontal line test. So what you're going to do is exactly what you've always done with the vertical line test. With the horizontal line test, what you do is you draw from left to right. Notice that drawing from left to right, you touch every single time just once. So if it passes the horizontal line test, it is 1-to-1. And that's how you do those. Okay, last and not the least. So let's look at this. These are very easy. All I need you to do is analyze the increase and decrease of these segments, segment 1, 2, and 3. You read a graph from left to right. As you've been noticing, all I've been doing is tracing the graph. So if you look at my cursor, it goes up. That means increasing. My cursor goes down. It's decreasing. My cursor goes up. It's increasing. So in this paragraph down here, I need you to classify what's happening with each of the segments from left to right. So the first segment we said was increasing. The second segment we said was decreasing. And the third segment we said was increasing. Then in these spots, I need you to tell me from what x value to what x value was it increasing for segment number 1. Well, segment number 1 started here at x equals -2, and it stopped at x equals +2. So I'll put -2, +2. So it increased from -2 less than x less than 2. Then it went from +2 all the way, it stopped decreasing here. So I go up to the x-axis at 5. And then it increased from right here, which is 5, all the way to 9. And that is all you do in this section. You are showing me that you are able to write the intervals of increase and decrease for these functions. And that is it. That was the lesson of section 1.3. So I hope that helps. If you have any questions, don't hesitate to reach out. Thanks again.